Let's take a look at this example. We have voltage equals 3 sine omega t plus pi over 3. Anytime you have a problem like this, you're supposed to realize that this is my voltage peak, positive, and this is my phase shift, which is expressed in radians, because I do not have degree sign. Now, in order to make this problem simple, I'm going to write the equation of the reference voltage, okay? This is going to be simply 3 sine omega t. It's always good to draw first the reference wave. Reference wave is simply the wave without the phase shift. This is not the answer, but this is the wave which is going to help me to find the answer. As I said, this is the peak value. This is voltage peak, which is equal 3 volts because I'm talking about volts. And this is my phase shift in radians, pi over 3. Next, I'm going to draw the graph. Y-axis is my voltage in volts, and my x-axis is my theta in radians. Because I'm dealing with radians, I'm going to put my angles in radians. So this is pi, and this is 2 pi. My peak values are 3 volts and negative 3 volts. I'm going to draw the dashed lines in order to make the wave look symmetrical. I'm talking about the sine wave at this moment. You have to keep in mind that the sine wave, which has voltage peak in this equation, positive, is going to have peak value at pi over 2. And negative peak value at 3 pi over 2. Okay, this is going to be my reference sine wave. I have to connect all these points together. This is my reference, V reference. This is not my answer yet. This waveform has to help me to find the answer. One more time, anytime you have positive sign next to the phase shift angle, means your reference waveform has to be moved to the left by the phase shift angle, pi over 3. How much is pi over 3? Let's take a look. We have to divide pi into 3 pieces. So I'm going to have something like this. And also, this distance I'm going to divide into 3. Now, we said this waveform has to be moved to the left side by pi over 3. That's why I'm going to have negative pi over 3 on the left side of my origin. Next, I'm going to shift this wave by pi over 3. Means I have to move origin by pi over 3, so it's going to be negative pi over 3. Pi over 2 has to be moved by pi over 3. How I can find the value of my new angle? I'm going to have pi over 2 minus pi over 3, which is going to be equal. Common denominator is 6. I'm going to have 3 pi over 6 minus 2 pi over 6, which is equal pi over 6. Means my positive peak value has to be at angle pi over 6. Next, I have to move my pi by pi over 3 to the left side. So simply subtract pi minus pi over 3. The common denominator is 3. That's why I'm going to have 3 pi over 3 minus pi over 3, which is equal 2 pi over 3. This is going to be 2 pi over 3. Next, I have to move 3 pi over 2 by pi over 3. This is going to be 3 pi over 2 minus pi over 3. Common denominator is 6. That's why I'm going to have 9 pi over 6 minus 2 pi over 6, which is equal 7 pi over 6. This is going to be 7 pi over 6. Next, I have to move my 2 pi by pi over 3. So I'm going to have 2 pi minus pi over 3. Common denominator is 3. That's why I'm going to have 6 pi minus pi over 3, which is equal 5 pi over 3. That's why I'm going to have 5 pi over 3. Next, I'm supposed to connect all these points together. I mean, the new positive peak. Next, we're supposed to mark the negative going, 0 crossing, 2 pi over 3. And we are going to have negative peak at 7 pi over 6. And we are going to have positive going, 0 crossing at 5 pi over 3. Next, we're supposed to connect all these points together. And this waveform is my answer. Let's take a look at this example. We have I minus 5 cosine omega t minus pi over 2. What you're supposed to do? Write the equation of the reference wave first. Means you have to write the equation without the phase shift. Simply copy down I equals minus 5 cosine omega t. I'm going to call this reference. Reference is not my answer. Reference is going to help me to find the answer. What I'm supposed to do next? I'm supposed to understand that this is my peak current. This is I peak equals minus 5 amps. Amps because I'm looking for current. And this is my phase shift. This is my theta. Now, please notice that anytime we do not have degree sign, means we talk in terms of radians. So you have to make sure that on your graph, x-axis is going to be calibrated in radians. Next, I'm going to draw xy plane. This is my current in amps. And my x-axis has to represent the angles in radians. Anytime you are going to deal with radians, you have to find pi and 2 pi if you want to draw just one cycle. Next, peak values. I have 5 amps and I have -5. It's always good to draw the dash line in order to make the wave looking symmetrical. Next, cosine wave. Anytime we talk about the cosine wave, you have to make sure that cosine wave is going to start always from the maximum value. I mean maximum, negative or positive. In this case, we're going to start from negative maximum. I'm going to start from here. Anytime we talk about cosine wave, which has no phase shift angle, this cosine wave is going to start from 0. And if it's going to start from 0, the very important points for this cosine waves are pi over 2, pi, and 3 pi over 2 and 2 pi. Remember, cosine wave, which starts from 0, is going to have peak value at pi. In this case, we're starting from negative peak. That's why at pi, I'm going to have positive peak. So my cosine wave is going to look like this. Approximately. Is it the answer to the problem? No. This is just the reference wave, which is going to help me to find the answer. Next, we have to get back to the original problem. Negative pi over 2. Negative pi over 2 is telling me that my reference wave is shifted to the right side by this angle. Negative is telling me that we have to move the wave to the right side. Many students are very confused about it, but you have to keep in mind, anytime you have positive sign, you have to move your wave to the left side. Anytime you have negative sign, you have to move your wave to the right side by pi over 2. So this is pi over 2. Means I have to move my negative peak to this point. My 0 crossing, positive going, is going to be moved to pi. My negative going 0 crossing is going to be moved to 2 pi, and my 2 pi is going to be moved to this point, which is simply 2 pi plus my phase shift, which is pi over 2. 2 pi plus pi over 2 is going to be equal. Common denominator is going to be 2. That's why I'm going to have 4 pi over 2 plus pi over 2. 4 pi plus pi is 5 pi over 2. So this is going to be 5 pi over 2. Now I can draw my wave. My wave is going to look like this. I have positive peak over here. Okay, so this is my I reference, and this is my answer I, which is simply the answer to the problem.